Welcome to ICT applications. Today I will be talking about output devices. In the previous lesson, we discussed about input devices and different types of input devices. Now in this lesson, we will discuss about output devices of a computer system. After completing this lesson, you will be able to understand different types of output devices. Also, you will be able to understand what is an output device and also to describe output devices. While input devices introduce data to the computer, output devices get the information out of the computer. Output devices communicate information to users in several ways, as printed documents or displaying images or by showing videos on screen. So this lesson introduces you to output devices and importance of those devices. Output devices translate the symbols processed by the system unit into words, sounds, images, and actions that people can understand. We can classify output devices into 4 categories as visual, data, print, and audio. Let's identify different types of output devices. Monitor. It is the most frequently used output device on PCs. The monitor is similar to a television screen. It allows you to see the programs or data. We can classify monitors based on the technology used and display colors. Monitors are categorized by the technology they use as cathode ray monitors, flat panel displays, and curved displays. Also, monitors are categorized by the way they display colors. Monochrome, one color on a black background. Grayscale, shades of gray on a white or off-white background. Color, it can vary from 16 to 16 million unique colors. Let us go through main types of monitors available today. CRT monitor or cathode ray tube monitor. This is one of the most traditional computer monitors. It is big and bulky. The process of a CRT monitor is as follows. In CRT monitors, electrons are fired at phosphor dots on the screen. The dots are grouped into pixels, which glow when struck by electrons. In colored CRTs, each pixel contains a red, green, and blue dot. These glow at varying intensities to produce color images. As you can see in this image, CRT has an electron gun at its back. The gun fires an electron beams at once through a magnetic yoke that aims the beam to the screen. The screen is coated with a chemical called phosphors that glow when struck by electron beams. This phosphor coating is organized into grid of dots where smallest number of dots that can be focused by the magnetic coil at once is called a pixel. The electron gun starts shooting electron beams from the top left corner and continues shooting until it reaches the end of the row. Then the gun starts shooting from the first pixel on the second row from top and continues shooting until it reaches the end of the second row of pixels. This process will continue for all the pixels. Flat panel monitor. They are developed as a solution of portable monitors and even are used in desktop systems. Liquid crystal display or LCD is the most common type of flat panel monitors. LCD monitor creates images with a special kind of liquid crystal that is normally transparent and become opaque when charged with electricity. Because they are in liquid form, they are easily manipulatable, and this allows us to play with the way that light interacts with them. If you have a flat panel in front of you, try just pressing gently on the surface. You can see the crystals move around and alter the picture. There are few layers on an LCD monitor. Let us go through them in the next slide. The LCD works on the principle of blocking light. Here, the polarization is a process in which the vibration of light waves is restricted to a single plane, resulting in the formation of light waves known as polarized light. Since liquid crystals do not produce light of their own, they need an external light source to work. Therefore, at the back is a layer of cold cathode fluorescent backlighting, which we call as CCFL backlighting. Then in the middle, liquid crystal is sandwiched between two pieces of glass or transparent plastic. In front is a layer of red, green, and blue color filters. When the external light passes through one of the polarized glasses, an electric current is generated on the liquid crystal molecules. They align themselves in such a way that polarized light travels from the first layer to the second polarized glass, causing an image to appear on the screen. We can identify several types of LCD monitors. Passive matrix LCD, active matrix LCD, and thin film transistor LCD. Passive matrix LCD uses a transistor for each row and column of pixels. Here, by altering the electrical charge at a given intersection, the color and the brightness of the corresponding pixel can be changed. It is less expensive, has a narrow viewing angle, and animated graphics can be blurry. Active matrix LCD uses a transistor for each pixel on the screen. It is expensive compared to passive matrix LCD. Also, it has a wider viewing angle, and also refresh rate is faster compared to passive matrix LCD. Then in thin film transistor or in TFT displays, it uses multiple transistors for each pixel. Since passive matrix monitors do not display fast motion well, most modern flat panel screen displays use active matrix or TFT technology. However, passive matrix displays are still being used in some smaller devices since they are less expensive to produce. LED monitor. It is short for light emitting diode monitor. An LED monitor or LED display is a flat screen, flat panel computer monitor or television. We can say all LED monitors are LCD monitors, but not all LCD monitors are LEDs. Therefore, it is also known as LED, LCD monitor. The actual difference between this and a typical LCD monitor is the backlighting. LCD monitor uses fluorescent backlight, which we call as CCFL. But in LED monitors, they use light emitting diodes backlight. There are two types of LED backlighting, full array backlighting and edge lighting. In full array backlighting, the LEDs are placed evenly across the entire screen, similar to an LCD setup. In edge lighting, LEDs are placed along the edge of the screen rather than behind it. It can be placed along the bottom of the screen, along the top and bottom of the screen, along the left and right side of the screen, or along all the four sides of the screen. LED monitors usually have a superior picture quality compared to LCD monitors. We can identify several variations as organic light emitting diode or OLED and quantum dots light emitting diode QLED. Curved monitor. Curved monitor provides more immersive experience and it is more comfortable to eyes. The curvature of the monitor allows our eyes to take in everything at once without strain. Flat screens, which depend on the size, may cause eye strain if the screen exceeds a viewer's natural field of view. Curvature is denoted as shown here. For example, we can consider common curvatures like 4000R, 3000R, 1800R, and 1500R. Here, 4000R indicate the radius with millimeters as the unit of measure. Smaller the radius, the larger the magnitude of bending. For example, 3000R is more curved than 4000R. In today's digital world, we are exposed to different types of monitors. We spend most of our time sitting in front of different types of monitors for playing games, watching movies, and many other things. These are several characteristics of a monitor that can be used to compare monitors. Size, resolution, refresh rate, dot pitch, color depth are some of those factors. Here you can see some factors extracted from my laptop. Size of the monitor. A monitor size is the diagonal measurement of its face or viewing area in inches. 15-inch monitors having 13-inch viewing area and 17-inch monitors having 15-inch viewing area are the most commonly used monitors. Here in this image, you can see how the monitor size is measured. Also, large monitors can be expensive. Next, we have resolution. Resolution is the number of pixels on the screen or on the display monitor. It is expressed as a matrix. For a given size of monitor, the larger the resolution, better the clarity of the image. So you can see that in this image. Let us try to understand resolution better. Resolution is the number of pixels contained on a display monitor. You can see the example shown here. As shown in figure 1, it has a lower number of pixels, and in figure 2, it has larger number of pixels. Both figures are equal in the size and represent a letter A. But you can see figure 2 is much more clearer compared to figure 1. Refresh rate. It is the how many times per second the display is able to draw a new image. It is measured in hertz or cycles per second. For example, in your display, let's assume has a refresh rate of 60 hertz. That means it is refreshing the image 60 times per second. Refresh rate in CRT is the number of times each second that the electron gun scans the screen's pixels. So you can see in this image, the electron gun scans from left to right and from top to bottom. Then refreshing every phosphor dot in a zigzag pattern. So fast scanning means quick refresh. That means less flicker. Next, let's move on to dot pitch or pixel pitch. It is the distance between subpixels of the same color in pixel triads. In color monitors, 3 dots, that is red, green, and blue, comprise each pixel. It is used to specify the sharpness of the display. The distance is very small and is typically measured in fractions of millimeters. Since pixel pitch indicates amount of space between two pixels, a smaller pixel pitch means there is less empty space between pixels. That is, the image would look sharper. Most LCD displays have a dot pitch between 0.2 and 0.28 millimeters. Some high-end displays used for scientific or medical purposes have a dot pitch as low as 0.15 millimeters. In this image, you can see 3 dots in 1 pixel. They are in red, green, and blue. Also, you can see the dot pitch, that is the diagonal distance between subpixels of the same color. Finally, we can move on to color depth. It is also known as bit depth or pixel depth. It is the number of bits per pixel on a computer monitor to represent a specific color. The more bits per pixel, the higher color variety and quality of the monitor also depends on that. 1 bit color is used in monochrome or in black and white monitors. Today, most computers support at least 32 bits, which allows for up to 16.7 million unique colors. Printer. This output device is used to get the process information on paper. We call these printed papers as hard copies. Several types of printers are used in computers, namely inkjet, laser, thermal, and dot matrix. Let's go through them one by one. Inkjet printer. An inkjet printer sprays small droplets of ink at high speed onto the surface of the paper. This process not only generates a letter quality image, but also allows printing to be done in a range of colors. The most photo printers that are used to print photos are special purpose inkjet printers. Next, we have laser printers. This uses a technology that is similar to photocopy machine. The laser printer uses a laser beam to produce images with excellent letter and graphics quality. These are more expensive than inkjet printers and are used in applications requesting high quality output. Next, we have thermal printer. These printers use better elements to produce images on heat-sensitive paper. Originally, these papers were used in scientific labs to record data. But of late, color thermal printers are used to produce very high quality color artwork and text. Compared with other types, these printers are very costly. Dot matrix printer. These printers form characteristics and images using a series of small pins on a print head. This was widely used in microcomputers some time back since they were inexpensive and reliable. But one advantage is that dot matrix printers are quite noisy. The quality of the printed material would be low compared to other types of printers. A plotter is a printer designed for printing vector graphics. Instead of printing individual dots on the paper, plotter draw continuous lines. This makes plotters ideal for printing architectural blueprints, engineering designs, and other CAD drawings. Projector, a device that projects compute output onto a white or silver fabric screen that can be a wall, a ceiling, or a tripod mounted. It is widely used in classrooms and auditoriums for instruction and slide presentations. A speaker is the key output device of sound. The sound system includes speakers and a sound card. The sound card translates digital signals to analog signals that drive speakers. With the right software, you can use your PC to edit sounds and create special sound effects. Headphone and headset. Many computer users prefer to listen to audio through headphones and headsets rather than through speakers. In these devices, audio can be played without disturbing others. You have to go to your PC and try to change the display settings in your PC, and you have to explore how it impacts things seen on the screen. Other than having separate input devices and output devices, there are some devices that can be considered as both input and output devices. Let's go through them one by one. Touch screen. It is available in laptops and in smartphones. Then modem. Modem takes signals from one internet service provider and translates them into signals that your local device can use, and vice versa. Then headset acts as both speaker and microphone. We have USB pen drives, CD and DVD to copy output and also to provide input to the computer. Then all-in-one printer or 3-in-1 printer has the functions of printing, scanning, and copying. Finally, we can consider GPS device. GPS navigation devices are able to capture your real-time location, and it shows route plan and detailed direction information to the user. To summarize, in this lesson, we discuss about different types of output devices. Monitor is the main output device that is used to display the output. Other than that, there are printers and sound systems. Also, there are some devices that support both input and output functions. In next lesson, we will go through about central processing unit. Thank you.